Hi, I'm Dizzy McGinnis. You've seen me in such fine quality chemistry educational videos as Chem Lab Equipment, Part 0, and Chem Lab Equipment, Part 5. Today we're looking at the basic lab equipment that you would find in a chemistry lab. Not all of them we're going to be using this here, but they're there, all the same, for the sake of completion. First one, dropper bottle. Whole point about the dropper bottle, ladies and gentlemen, is you're going to be adding chemicals at some point during the year, and you may need to add a few drops in order to get something to happen. Sometimes the dropper bottles are glass like this with the little dropper thing, or they can be plastic where you actually squeeze out the drops. Both ways work. The test tube. Pretty stereotyped in chemistry. The test tube, we can hold things, we can also mix things in there, we can also heat things up in there. They do come in different sizes, like you see here. Sometimes they're short and relatively wide. Some of them, they're very tall and very thin. The spatula. Use it for scooping powder, or maybe pellets from a chemical bottle into your beaker or your flask. You'll notice one end kind of looks like a shovel. The other end is very flat. Same job for both sides. You're using it for scooping stuff into a container. Glass stirring rods. Glass stirring rods are pretty common. We do not use spoons in the chemistry lab. We use the glass stirring rods. We use them for mixing things by stirring in a circular motion, like so. Again, they do come in different sizes. The beaker. Wow. Just like the test tube, the beaker is pretty stereotyped in chemistry. We can mix things inside a beaker. We can heat things up inside a beaker. We can do a bunch of things with beakers. Now, they do come in different sizes, like you see here. In this case here, the one that's pictured is a 1,000 milliliter beaker. They do range from as tiny as 5 milliliter beakers all the way up to 2,000 milliliter beakers. And again, is that used for making exact measurements of volume? No, it's not. It gives us a rough idea about the volume of the solution that would be inside the beaker. This is also beaker, but not the real beaker. Wire gauze, used for heating. Sometimes we're going to need to heat a beaker or a flask or maybe a crucible. We'll get to that later. And instead of putting it in direct contact with the flame, we use the wire gauze. Now, you may notice, hey, it looks like a wire screen, and the white stuff there happens to be ceramic material. Yes, exactly. It's ceramic material. It's not asbestos. Okay. The Erlenmeyer flask, named after the guy who invented it, Erlenmeyer. The whole point about that flask, it's similar to a beaker. You can pour things in there and you can swish it around. You pick it up by the neck and then you swish it around in a circular motion. The idea is to combine everything, so you don't necessarily need a glass stirring rod to do that. Again, they do range in sizes from, let's say 25 milliliter Erlenmeyers all the way up to 2,000 or maybe 4,000 milliliter flasks. Test tube rack. That's pretty self-explanatory. Holds test tubes. It's made up of different material. In this case here, you're seeing it as wood. They're also made of plastic. They're made of metal. The size of the test tube holes themselves can vary. It depends on the kind of test tubes that the person has in the lab. Test tube clamp. Test tube clamps, they hold test tubes. Grabbing a test tube that may be hot can very well burn your hand, and that certainly would violate, chemical safety protocols. And we certainly don't want to do that. So the way to grab it is like this. Now, you may notice you squeeze in the center there, you see those little circles. You put pressure on it with your fingers from both sides, and then the rectangular part opens up. You put that around the test tube, and then you gently let it go, and the clamp will pick it up, will hold on to the test tube, and then you can pick it up. Now, when you're transporting it, or maybe you're holding it over a flame or something like that, it is important not to go and put pressure on it. The clamp's already doing the job, because if you put pressure on that clamp while you're holding it, then it's going to let go the test tube. Test tube can fall. Test tube can break. That would not be a fun activity. Funnel. You've seen these probably at home in the kitchen. They can be made of plastic, metal, or in this case, glass. There are different sized funnels depending what is needed to be done. The whole purpose of the funnel is to pour either liquids or maybe sometimes powders in through to a container, whether it's a beaker or a flask, with the idea that you are not spilling this out onto the table or wherever you are working. Now, sometimes we can use the funnel to filter out. That means remove some things. Like, let's say we have a solution and we have particles in that solution that we can't dissolve it. The funnel is useful for that because we can put special filter paper. Think like the coffee filter paper at home in the coffee maker. And we can put the filter paper into the funnel. We can pour the solution with the particles into the funnel with the filter paper. The liquid part of the solution goes into the container that you have, and then the leftover particles are trapped. They are trapped in the filter paper, and they're left out. And as a result, whether it's a beaker or a flask, you now have pure liquid as opposed to liquid mixed with those particles. So that's what we use the funnel for. Scoopula. It's a distant relative of Count Chocula. The whole purpose of the scoopula is to scoop powder. Now, some people might say, but wait a minute, what? We go back earlier in the video and you have the spatula. Right. The scoopula is more useful for scooping the powder than the spatula, although you can use the spatula to scoop out powder. It sort of looks like a tent peg that you would pound into the ground for camping. In this case here, this one is made of metal. No, it's not good for camping. It's not designed for that. It would more likely bend if you were trying to pound this into the ground. Tweezers, also known as forceps. As far as our chemistry course, we're not going to be using tweezers this time around. Certainly there's more application in a biology lab, perhaps like a dissection. Other than that, it's a very straightforward piece of equipment. Holy Batman, the utility clamp. Right, and we attach that to the ring stand. We'll get to the ring stand in a moment. The utility clamp, the whole point about that is to be able to attach other devices to a ring stand that we would use. Devices could be test tube, it could be rubber tubing, it could be some other instrument that you're using to measure something. So there's a lot of uses for that, which is why they call it the utility clamp. The ring stand. The ring stand forms the base of a chemistry experiment that we can attach different devices or appliances to the ring stand using the utility clamp. Now, some devices will have their own thing to screw that you can screw directly into the ring stand, and that's it. Graduated cylinders. This is where we get into precision and accuracy for chemistry. When you saw those pictures of the beakers earlier, and they had the numbers and the graduated markings, great. But that's not what you would use precise measurements. If we're talking about precise and accurate measurements in chemistry, we don't use the beaker for it. We use the graduated cylinder. Whole point about the graduated cylinder, we measure liquids. So if I needed to measure 26 milliliters of, let's say, water that I'm going to add to something, would I use a beaker to measure 26 milliliters, or would I use the graduated cylinder? We would use the graduated cylinder because it is marked that we can see the 26 milliliter reading. You are not going to have that in the beaker itself. You might get a 25 milliliter reading on the beaker, but then how in the world do you determine that last milliliter? And in chemistry, when we are preparing solutions, compounds, usually it's pretty important that we have to have the exact measurement, the exact volume measurement of a liquid or a solution. The iron ring. This is one of the items that we can attach to the ring stand. Now you may notice in that picture on the left-hand side, it has a screw-like apparatus that you can mount it onto the ring stand like you did with a utility clamp. Well, what would you use the iron ring for? Different purposes, but mostly it serves as a platform that we can heat up things. We would put the wire gauze on the iron ring, and then we would put our heat source underneath. Lab burner, also known as the Bunsen burner. Again, this is basically the heat source that most people use in a chemistry lab. There are different sizes of lab burners out there. The one in this picture is connected to a tubing that is connected to a gas valve. At the bottom of the burner, you may notice that it is kind of closed there. For us, we don't need to have any extra air going into the gas while we're lighting it up. It works fine without any extra air added in, and we get a good flame, and that's a pretty important thing. Droppers, also known as dropper pipettes. Really simple. We need to add drops of something. These are the guys to do it. Now, they do, again, come in different sizes. It depends how many milliliters you have. Evaporating dish. Well, the whole point about the evaporating dish is that we're evaporating crystals in there. Dehydrating crystals typically, where water's attached to a crystal, we can heat it up and get rid of the water. Now, the dish itself is made of porcelain, so it is fragile, but it also withstands a lot of heat as a result. Crucible and cover, heating things up with that. It's similar to the evaporating dish. We could evaporate crystals in that without the cover, but sometimes we need to heat things up, and we use the cover to keep the heat in, much like the lid on a pot that's on the stove in the kitchen at home. Again, it is made of porcelain. Graduated measuring pipette. Well, again, it looks like a long dropper, and it is graduated, so it has a lot of the little lines in there. And we use that, again, for specific measurement. It is very similar to those plastic pipettes you saw earlier, the dropper pipettes, except in this case here, this gets to be more precise for whatever volume you are measuring. Well, at this point, I'm going to stop here and call an end to this for part 1. This is the end of part 1. There is a part 2, and we're going to get to that in a moment.